Well, let us move on to the next inner class, which is the local inner class. So local inner class is a class which is defined within a method. So let me define a method, say show, and a class within this method, say a local inner class. So I can even define any method within this class. So let us pin down the rules that are applicable to our local inner class. The rule number 1 is, since it is defined within a method, it cannot be accessed outside the method. So the scope of the class is limited to the method itself. So nobody outside the method show knows that there is a class within this method. Now rule number 2 says, the access rule, which specifies what variables it can access. Suppose I have an instance variable, say x, I have a static variable, say y. Now this class can access everything from the outer class, x plus y. So this class can access everything from the outer class subject to the scope of the method. Now scope of the method means that in case this method is static, so the visibility of instance variables will be a problem inside a static method. So that is the limitation that applies to it. Otherwise, if the method is instance, then it can access to any variable of the outer class. Now another important rule is that the only access modifier you can apply to this is either abstract, means this class can either be abstract, but declaring such a class as abstract would be meaningless, because then you need another class to override this class, and then you'll need another class within the method itself. So there's no point declaring it abstract. And second is, you can declare it as final. However, no access modifier you can attach to it, such as public or private. You can only have a modifier which is package. So it says it can only have abstract or final. So we have seen that a class within a method has a scope within the method. Now it can declare some variable by itself. Now can it declare anything static? No. Now anything static cannot be declared within a non-static block. So this class cannot declare anything which is static. So next, the most important observation or rule for this is regarding to the local variables. Now variables which are declared within the method show. So if I declare any variable, say k, now in case I am accessing this variable k from within the class, I need to make this variable as final. So this is the most important rule that applies to a local inner class. So I'll just pin down. The third rule was, can't declare anything static. Rule number 4 is that local variables need to be declared final. Now this is some important point that needs some observation. Now why this needs to be final? Now as we have already discussed during the last lecture, the implementation of inner classes in Java is that the compiler takes this class out and implements this as a top level class. So this becomes an altogether independent top level class, and LIC also becomes a top level class, which already it is, But the main point of observation is that this class becomes a top level class, and when it becomes a top level class, how does it access this variable k which is declared within the method show of class LIC? So this is where the problem arises in the access of this variable k. Now in case I make this as final, which is mandatory for any local variable, then what system does is it replaces the value it replaces the variable k with the value in the compiled class. So we'll just first run this and then we'll see the class file for this class. In case I need to call this method show1 of class ALIC, I'll create an object of class LIC and then I'll say l dot show, but we haven't put to any use this class, so I'll create an object for this class within the method and I can say a dot show1. So this is how we can use a local inner class. We have to use within the method show. So this is the only place where I can utilize the class ALIC, which is the local inner class. So we'll just run and see the output. So the output is 100. So it is just addition of all the variables. So now let us see what exactly has happened to this local variable in the compiled class. So I'll just copy this, take it to my notepad, compile it, and then let us first see what class file it has generated for the inner class. Now I have lic.class for the outer class, lic$1 alic.class is for the inner class. So I need to explore this class to see what exactly has happened to the variable k. So we'll keep it alongside this class to see what has happened to this class. Now I'll write java p, the tool to see the class file disassembler, lic$1 alic, and that. Now same as in case of an inner class, we have a reference to the outer class variable. We have a variable this $0 type the outer class, which will be initiated through the instantiated through the constructor, and which is through which the local inner class keeps a track of the outer class. So this is the entire data referred. The entire data for the outer class is referred by the inner class through this object, this $0, which is instantiated through the constructor. Now let us find out what has happened to the variable k in the method show1. So I have the method show1, and here we have, it says by push 40. So this is the statement. It says that it is pushing the value 40 instead of the variable k. So for the variable k, wherever we use this variable k, the system will push down a value which is 40. So it has replaced k with a value that we have passed to k. Now what happens if k is not initialized in the method show? So let us make some correction to this. Instead of defining the variable with a value, I'll declare it as a parameter to the show method, final int k. So I'll need to pass some value to this method to complete the call. Right. So earlier the variable was declared with a value, so the system had replaced the variable with the value. Now because this is a variable which is to be passed a value at runtime, so system is not aware of any value which this variable will be getting. So how does it now replace k with? Because k has no value at compile time. So in this case, what system does is it creates a variable and passes the value of k to it, and stores it within the class ALIC, as we'll just see after compiling the class. Java C. Oh, I have already, yeah. So now we can see the difference in the constructor. Earlier we had a constructor with only one parameter, that of the outer class, whereas in this case we have a constructor that is having a constructor with two values. One is which is the reference to the outer class object, and second is the int value, which is the local variable that is passed to the show method. So this it has stored in a int variable called val $k. So in the constructor it passes the value, this int value, to this val $k, and wherever we are referring to k, it is referring that to val $k. So this is the variable that stores the value of k and keeps its value within the class when the class is implemented as a top level class. So this is how this all has been implemented. For a simple value, as we have in this case, the compiler simply replaces this with the value of the variable, and in case it is a variable which happens to be passed a value at runtime, it keeps a local variable within the class and passes the value of k to it and keeps a track of this value throughout the life cycle. So this final is to make sure, had it not been final, suppose I make a change to it somewhere here. So this means we are making a change to the variable, but the class already has taken this value k equal to 40 within the class and must have processed according to the value of k equal to 40, whereas we have further made changes to this k. So we don't want changes to be made to k that are not reflected within the class, so we have made this as final so that there is no change to the value once it has been taken out by the class. So this is a local inner class within a method. So we have seen the rules that apply to it and how the class has been implemented by the compiler, and how and why this variable has been declared final, and how the same has been accessed by the class. We have gone through by seeing the bytecode file. So this completes the local inner class. Next we'll see the anonymous inner class. Now in continuation with the last lecture of local inner class, a small point worth mentioning here is that as we have already seen in the class, the compiled class, that it keeps a reference to the object, and secondly it keeps a reference it keeps a copy of the variable within the class. So how does it does so? So suppose I keep a variable, say here, I'll just show a little code, this $0 which is of type LIC, and it keeps a variable, say int val $k. As we have already seen, it creates by this name. Now it creates a constructor of the class ALIC, has, say, something like this, and then it passes this $0 equal to a and gives val $k the value of kk. Now when the compiler it shifts this class as an outer class, it makes some changes to this statement also. As ALIC is no longer named as ALIC, it will be renamed as LIC $1 ALIC, So, and it needs to pass this, which is the current reference to the object, and the variable k. So this is how it is working. Instead of the class name ALIC, it writes the complete name. That would be the name of this class once this class is compiled and made into a separate top level class, and it passes the current object, which is the show method, keeps a reference to the current object, and then the k, the variable which is the local variable. So this k it passes to the val $k, and this current object it passes to this $0, and then it remains within the class, and wherever it needs to access, like x, it will write this $0.x, and for y it will simply write lic.y. For xx, that belongs to this class only, and for k it will write val $k. So this is what exactly happens in the compiled class. I hope this clears every aspect of the local inner class.